Good morning. Today, let's discuss the first chapter from A-level statistics, which is hypothesis testing. Hypothesis testing. It's an interesting chapter, and in this class, we are going to discuss the topics like hypothesis, significant level, confidence level, critical value, and critical region. So, our chapter name is hypothesis testing with learning objectives, hypothesis, significant level, confidence level, critical value, and critical region. Okay, before going to this topic, what do you mean by a hypothesis? Hypothesis. Okay, to get an idea about hypothesis, we will go through 2 or 3 examples. Like, for example, example 1. Like, in some TV channels, when you are thinking about some TV channels claims that all their programs are nature program, all their programs are related to something, a particular category. Okay, so a TV channel claims all their programs are nature programs. Just one of the examples. If you think about another example, like what we'll say about DNA in a certain court, court wants to test DNA. Okay, so based on the DNA produced in a court, the judge has to take a decision. Based on the DNA submitted in a court, the judge has to take the decision. So here, whether the decision is right or wrong. Okay, if you think another example, like if you say a survey states that 10% of the people in this world are left-handed. A survey states that 10% of the people in this world are left-handed. Okay, like this, a lot of examples can be made. So from all these examples, you could find something. These all examples or all these statements are about to claim something. All these examples are to claim something. Is it? A TV channel claims that all the programs are nature program. It's also a claim to test whether the result is positive, is right or wrong. The third example is also a claim that 10% of the people are left-handed. So, a hypothesis is a claim. So, what is a hypothesis? It is a claim. Okay, and we are not sure. It's a claim by someone. It's a claim by the TV channel. We are not sure whether this claim is right or wrong. So our task is to check whether the claim is right or wrong. So to test that claim or to test that hypothesis, We use the methods like sometimes we use scientific method when scientific research is required. There we use scientific method. But the questions like this here, instead of scientific method, we can use statistical method, because these are all things about this first and third. First and third is about survey. So statistical measures can be taken to claim whether, or to check, to test whether the claim is right or wrong. So to test a claim is right or wrong is considered as hypothesis testing. Okay. So hypothesis testing is a process to test whether a claim made by a particular company or particular person is right or wrong. So a hypothesis is a claim or a promise which is to be tested. Okay, so hypothesis testing is analysis of data in which whether the particular claim is true or false. That is what we need to test in this chapter. Okay, so if I take another example, a known example, like for example, let's have a set of dice. Suppose I have a set of dice, a set of dice. Among this set of dice, a few dice are fair and a few are biased. So a set of dice, among the set of dice, some are fair and some are biased. So when you are saying a die is biased, suppose I am selecting a die. Among the set of dice, I have few dice with me. Among those dice, I am selecting a die from that set. Now the die which is in my hand is whether a fair die or a biased one. To test whether the die is biased one, here we need some conditions to be provided by the person who claimed, the claimer. Okay, like for example, here the claim is like, suppose if you get all sixes by rolling a die, then it is biased. Just an example. Suppose I am rolling a die. N number of times I am rolling a die, and now all the times I am getting only 6. So here I can say my die is biased one. It's biased towards 6. Okay. So in this particular example, I have made a condition that if I get a 6, all the throws, all the experiments are giving me the number 6, then my die is biased. So that is my claim. My claim is my die is biased because all the experiments are giving me the result 6. Okay. So to test that claim, we need to test that claim. So to test that claim, what we do? We have to take the first die and we have to do the experiment several times. So how many times we have to do the experiment? Let's fix that. Okay. So suppose we are doing the experiment 16 times. So here we have a die. We have set of dice. Among the set of dice, we have selected one die. And we are doing the experiment 16 times. The experiment is throw the die and check whether your result is 6 or not. If you get maximum results are 6s, then the die is biased. Okay, so once again, so you have set of dice, and in those set of dice some are fair and some are biased, and in case of biased we need to give a condition. That condition is while doing the experiment, if you get all sixes, if you get all the results are sixes, then it is biased. And here you get a question, are you sure that you will get all our sixes? You will get a question. So you need to show your confidence level there. That is what I wrote, the learning objective, confidence level. So when you make a claim here, if you get all sixes, my claim, my general claim, die is mine. I am making a claim that all the throws gives me the result 6. Okay, so here the next person who is opposing that claim, no, it is not correct. No, it is not correct. All the throws never gives you 6. So here the question arises, are you sure? Yes, I am sure. How much you are sure? Yes, I am sure 100%. 100% I am sure. So if you use the term 100% there, the problem arises. Because when you are making 100%, you are not giving any chance for the other side. Because by chance, if your die gives you any other result, your claim becomes false there. So when a person is asking me, are you sure that you will get all the sixes? So there I am giving a confidence level. Yes, I am 95% sure. 95% I am confident that I am going to get all our sixes. Sorry, getting? So when you prepare, when you make a claim, you must show your confidence level also. Are you sure? All the people, when I have taken a survey, 10% of the people in this world are left-handed. Are you sure? Yes, I'm sure. How much? 90% sure. Because I couldn't do survey for all the people. Survey, survey is meant by a sample. So there, what the level we shows, what the surety we shows to the others, that is known as confidence level. It varies like 90, 91, 95, 99, etc. Okay. So in this question, when we consider this question, here your experiment is rolling a die. So throw a die. And our claim is, if you get the result as 6, if you get the result as 6, you are successful. If you get all the throws results are 6, you are successful and your die is biased. Your claim is true. Else by chance, if you do not get 6, there you failed. So your experiment is throw a die. Here you get only 2 results now. Either you are getting 6 or not getting 6. Don't get confused. Do we get only 2 results? No. You are going to get any of the 6 results. Maybe either 1, 2, 3, 4, 5 or 6. But this question is based on whether you get 6 or not. If you get 6, your die is biased. Not once within a fixed time. Like, okay. So in this experiment, you are facing 2 results. Either you get 6 or do not get a 6. Okay. So this experiment, when you look at this example, should come in your mind that this example is related to a distribution which you learned in AS level classes. Do you remember which distribution it is? A distribution which consists of only success or failure, win or loss, pass or fail. Yes, it is binomial distribution. It's nothing but binomial distribution. So remember, in hypothesis testing, we use a distribution named as binomial distribution. So what is binomial distribution? It's a distribution, or it's a display. It's a probability display which gives us only two results, either success or failure. Okay, and already we learned how to represent a binomial distribution. Let's take a random variable x. X is a random variable. If it follows binomial distribution, it will be having the parameters n and p. We have already learned all these things in AS level. X follows a binomial distribution with parameters n and p, where n is the total number of experiments and p is the probability of success. When you compare this one with our example is whether you get a 6 or not. And already we decided we are going to do the experiment 16 times with a probability of every 6 is 1 over 6, because there are total 6 outcomes. From that, only one outcome we are expecting, so 1 by 6. So here x follows a binomial distribution with parameters 16, 1 by 6. Okay. Now here what's your procedure? A procedure is nothing but we need to find probability of x is equal to 0. What do you mean by probability of x equal to 0? Yeah, it's nothing but when here x represent number of sixes obtained. Okay. So x is a random variable. In this particular example, our question is about whether how many sixes are obtained while throwing the dice 16 times. So x is a random variable. In this question, x is a random variable, represents number of sixes. Suppose you throw the dice 16 times. You threw the dice 16 times. You got x is equal to 0. Number of sixes is 0. So we need to find the probability of this one. We are not doing all the problems, just we are doing one example. And you know, when it is binomial distribution, probability is NCR into p raised to r into 1 minus p the whole raised to n minus r. So when you replace the value, n is 16, CR, r is 0, into p is the probability, which is 1 by 6, rise to 0 into 1 minus p, that is 1 minus 1 by 6, rise to 16 minus 0. Just find out this answer. When you calculate this answer, you get it is something 0.05, which is it's around 5%. So this 5% shows that your confidence level of getting 0 sixes is just 5%. Your confidence level of getting 0 sixes is 5%. Okay, continue this process with x is equal to 1, x is equal to 2, x is equal to 3, etc. Okay, so this is just an example. When you do this process and when you continue the number of experiments, we get a normal curve. Let's discuss this all process now with a normal curve. Like suppose let's take a normal curve. Just think that this normal curve is the whole process. This is the full process. Among this full process, like maybe throwing a die, or else this process, this experiment, this is the result of an experiment. Maybe 10% are left-handed, or DNA test, or whatever the experiment. Okay, among this experiment, we always use a confidence level. Like for example, your confidence level is 95%. If you say your confidence level is 95%, this confidence level is also named as acceptance region. Acceptance region, the region which can be accepted. Okay, so you have 95% confidence level means within this 95% region, whatever the things comes, you can accept it. So from here, if I make a 95% region, if you think this one as 100%, start thinking this is fully 100%, because you know the total probability is always 1. So if you make it as completely a normal curve, suppose this line represents 95%. So this full region is the confidence region. This region is named as confidence region. Okay, which gives you 95%, or in decimals it is 0.95. So the acceptance region, if you say your confidence level is 95%, whatever the values you get within 95%, it will be accepted. So if your acceptance region is 95%, now you think what is your rejection region? Rejection region is 5%. That is this region. This region is the rejecting region. It's also named as significant level. Significant level. A confidence region or confidence level is 95%, and so that significant level is 5%. Like if you think confidence level is represented with C and significant level is represented with alpha, then alpha is equal to 1 minus C. Alpha is equal to 1 minus C. Okay, just note down this one. Alpha is equal to 1 minus C. So here we got a few more points. We started from hypothesis. Hypothesis is a claim or process which is to be tested. When we are thinking about the claim or claim to be tested, there we have a very important concept which is confidence level, because there will be a question, what is your confidence level? So there you have to discuss about confidence level. Yes, I am 95% confidence. So when I am 95% confidence, that shows that you are not confident for 5%. That is significant level. Okay, that is significant level. So whatever the value you are getting within this significant level, if your result is within significant level, like for example in previous question we have calculated probability of x is equal to 0. We have calculated probability of, do you remember that? Probability of x is equal to 0. We calculated as 16C0 into 1 by 6 raised to 0 into 5 by 6 raised to 16. So when we have calculated this value, actually what we have got is, just let me check, using our Z table, when we have calculated that value, we got the result as 0.0541. When we find P of x is equal to 0, There we got the result as 0.0541, which is equivalent to 5.41%. Which is equal to 5.41%, is it? Yes. So, when you look at this 5.41% and the significant level, this 5.41% is more than the significant level. 5.41% is more, significant level is only 5%. So 5.41% is more than the significant level. That means if it is within the significant level, we can say that your result is in rejection region. Significant level is rejection region. You got 5.41%. Instead of this, suppose you got it as something 4.8%. Example it is. Instead of this, you got the probability as 4.8%. You know 4.8% lies within 5%. It's smaller than 5%, is it? 4.8 is smaller than 5. So there we can say 4.8% is lying within the significant level, or it lies within the rejection region. So there we can reject the actual claim. But in this question, when you consider P of x is equal to 0, we got it as 5.41%. And your significant level is 5%. So 5.41%, when you are thinking 5.41, this 5.41 is higher than 5. That means this result is not within the rejection region. So this result comes in the accepting region also. When you make this result, this result is not only in rejection region, it comes out of rejection region. That means in such case you have to accept the original hypothesis, original claim. Okay, so it's a bit confusing, but when you think once again, it will be very easy. So in your total results, when you are considering our whole result, 100% result can be divided into two parts based on our confidence level. If our confidence level is, suppose our confidence level is now 90%. Like I have made a claim and I'm confident only 90%. That means my significant level is 10%. And also you have to remember the other word for confidence level is nothing but acceptance region. So let's make 90% here. Like suppose up to here is 90%. Up to here is 90%. This region is 90%. So this region is acceptance region. If your probability comes in this region, you have to accept the claim. Okay. And the other region, the other tail, the right tail of this curve, this is the rejecting region. Rejecting region. If your probability, if your results comes within this region, that means like you got significant level as 10%. So if your probability results is within 10%, within 10% means from 0% to 9.9%. Then you have to reject the claim. Like for example, you found the probability of something. You found the probability of an event. You got it as 9.8% in percentage. When you find the probability of an event, probability of a claim, you got it as 9.8%. So now you have to compare this probability with significant level. Significant level is 10%. That means the rejection region is 10%. And your answer is smaller than that. That means your answer lies within this only. That means your probability of that event is in the rejecting region. So we have to reject the claim. Got it? Suppose instead of that you got it as 19.8%. When you calculate the probability of an event, it is 19.8%. So there you have to understand your significant level is 10%, but your answer is 19.8%. That means your claim is giving you 19.8%. That means your answer is beyond the significant level. That means it comes in confidence level also. So in such case, we have to accept the claim. Okay. So these are the crosses we need to do. Now we are using always claim, initial claim, second claim, third claim, etc. So instead of that, we need to use specific terms. Like for every question, like we have made a question here. The first question was a TV channel claims. A TV channel claims that all their programs are based on nature. A TV channel claims that all their programs are nature-based programs. This is a general claim made by the person, the channel. Okay, that claim, the first initial claim or general claim is named as null hypothesis. Null hypothesis. The initial claim. Suppose I am making a claim that 10% of the people in this world are left-handed. That is a claim by myself. So it is your task to accept my claim or reject my claim. It's up to you whether you accept or reject my claim. So if you want to accept my claim or reject my claim, you have to show the evidence. Statistical evidence. So that initial claim or general claim is named as null hypothesis, denoted with H0. H0. Okay. Now, to accept my claim or reject my claim, you made a claim. You will say, no, I am not sure. I think it is more than 10%. Is it? When you are talking, you will say, yo, no, I don't think. I think it is more than 10%. Or I think it is less than 10%. So the second claim which you prepared, which you made, is alternate hypothesis. Alternate hypothesis. Denoted by H1. So the initial claim made by me, suppose I am making a general claim. I am making a general claim as 10% are left-handed. This is a claim by me. That's a general claim. Now another person, a person A, he opposes this claim and he says, no, I don't think this is correct. I think more than 10% are left-handed. So a new claim is formed here. That is named as alternate hypothesis, which is H1. It's also denoted with HA. But here we are going to denote H1 because 0 and 1. It's almost similar. Okay. So we call this claim as H0 and this is H1. Okay. So once again, just revise. We started with hypothesis. Hypothesis is nothing but it is a promise or a claim which is to be tested scientifically or statistically. Okay, so when we test a claim or a promise, the general claim or the initial claim is named as null hypothesis, and the claim which is formed later based on the null hypothesis is alternate hypothesis, which is H1. Okay. So now here when you make a claim, you have to show a confidence level of maybe 90%. Don't show confidence level anytime less than 90%. If you say yes, are you confident? Yes, I am 75% confident, or I am 80% confident. That shows that you are not confident. When you make a claim, it should be 90 or above. Suitably 95. Okay. And that claim, that confidence level or significant level will be provided in every question paper. In every question. Okay. So when you are preparing a claim, there should be a confidence level. That confidence level gives you a region named as acceptance region. So if your confidence level or acceptance region is 95%, then you can say your rejection region is 5%. Because 95 plus 5 is 100% total. That rejecting region is also named as significant level. Significant level. Okay. So here you get two terms, significant level or rejection region and confidence level or accepting region. Now, whether you accept the null hypothesis or reject the null hypothesis is based on your significant level. Your significant level gives you the idea whether you should accept null hypothesis or reject null hypothesis. Like already we discussed, suppose this is your significant level or level of significance denoted with alpha. If your probability of an event is within this significant level, like suppose significant level is 5% and your probability is simply 3%, you can say your probability is smaller than significant level. That means the probability is completely lying in significant level. That means rejecting region. Significant level is also rejecting region. So your probability is completely within the significant level. That means you have to reject H0. You have to reject the claim. Reject the claim means reject H0. So in this case, reject H0. In another situation, if probability of an event is suppose 6%, your probability of an event is 6%, but your level of significance is just 5%. So here you could find probability is higher than significant level. That means your probability value goes beyond the significant level. That means it comes in accepting region also. So what you will do? We have to accept H0. So here you get an idea when to reject H0 and when to accept H0. So we reject H0 when P value means probability value of the probability. When P value is smaller than significant level, reject H0. And if P value is higher than significant level, accept H0. Okay. So in every problem of hypothesis testing, you have to identify the random variable. Random variable means this question is about what? About what claim? You have to identify the parameters. You have to identify whether it is a binomial distribution. Now, you have to identify what is the significant level. Then, You have to find the probability value according to the question. Find the probability value and check whether the probability value is lower than significant level or higher than significant level. If probability value is lower than significant level, reject H0, and if it is higher than significant level, accept H0. So this is the initial part of hypothesis testing. Thank you.